Okay, well, last time we had a relatively long lecture on Mecham, uh, setting up a humanoid character and how to make them walk and run and jump and do all the different things. Today I want to extend this to AIs, artificial intelligence, NPCs, whatever you want to call them. So let me get my slides up here. So we're going to use Mecham, and kind of the really great thing about Mecham is we can use exactly the same controllers for our AIs that we use for our characters. That we have idle, run, and jump states, and they're controlled by various parameters: speed, direction, and jump. And we'll just write controller scripts that define those parameters. And our character will perform what we want it to do as we go through our different AI, our different artificial behaviors. We're not really doing artificial intelligence. These aren't thinking creatures. These are maybe artificial behaviors, but I'm going to call them AIs. And the basic thing that any of our little creatures will know is where the player is, and as appropriate, they'll either approach or avoid them. They can either follow or flee, and of course attack. And we might also have some kind of random movement for when they're not targeting the player. So they won't just move to the player in a straight line. They'll do various stuff. This idle function later maybe will turn into an attack function. So let's talk about random movement first, or wandering. The first thing about building these AIs is we're not going to put their behavior in the update function. We're going to instead put it in a while loop in the start function that I'll make into a coroutine. I'll make the start function a coroutine by making its type enumerator instead of void. For this to work, we're going to be using the yield command. The yield command says release this function for either one frame or for a specified amount of time, or until the coroutine finishes. So with our WanderingAI, we'll start with a bunch of exposed variables. I'm going to work with two circles, an outer distance and an inner distance, and you'll see the reason for them as we go along. I'm also going to have some parameters for the damping, both of the speed and the direction. So this will control how our parameters respond as we set them. In start, I'm going to, of course, cache my animator with a get component. I'm going to call a function reset direction that specifies a random point that we're going to go to. And I'm also going to have a timer, so I'll catch the start time. And then I enter this while true loop that each pass through the loop does a yield return start coroutine idle. So as a coroutine that is yielded, it's going to block at this point, because this is a coroutine, and it won't continue around the while loop until idle finishes. Reset direction, I'm going to use a random inside unit circle. So this returns a vector 2 that is just a random x and y position inside a unit circle. And I'll catch the x and y components of that vector 2, and I'll use that to set the target position to be x, 0, and z. And then I'm going to move that from my animator's root position. When we're working with these animators, we have a lot of access to where they are, their root position. I believe there's a center of mass position too. But we also have their root rotation, how they're oriented, things like their angular velocity, how they're spinning, and their velocity, how they're moving. So the animator gives us a lot of information about what the character is doing. So I've set a target position with this random number generator. So now the idle function. Don't worry, I'm going to blow this up in a minute. But this is all there is to the idle function. It's a coroutine. I enumerator idle. I've got a little trap here to make sure that I have an animator. I should have an animator, but just a little trap here. First thing I'm gonna do is generate some random activity. You remember my character has the ability to jump and slide, although I think I replaced the slide with a dive. And we have the ability to change the target with reset direction. So I'm going to throw a random range. This is going to return a number between 0 and 499. And if that number ever comes up to be 20, I'm going to set the Boolean jump in my animator controller that's going to make my character jump. If the number ever comes up at 23, I'll have them dive. And if the number ever comes up at 20, I'll reset the direction. It's a 1 in 500 chance of any of those things happening. So with my WanderingAI, with the orientation, we've got speed, which is going to move our character forward. And we have direction that turns them to the right or to the left. The speed, and with our characters, we based on v squared plus h squared. But with our AIs, we don't really need to do that. We can just set the speed to be either 0 or 1. We've got that damping that'll slow how it goes to from 0 or 1. The direction, as you recall, went from -1 for a left turn to +1 for a right turn. And so we're going to have to generate that. We'll use a little trigonometry here, or vector math, actually. The dot product of two vectors gives me the cosine of the angle between them. So if I dot two vectors together and the dot product is positive, it means that we're facing our target. The two vectors are our vector that we're facing forward and the vector to our target. So if that angle is positive, we're going to have a positive dot product, and it'll be negative if we're facing away from our target. So we can get the amount that we need to turn from the cross product of two vectors, which gives us basically the sine of the angle between them. So if the cross product is positive, it means we're going to be turning to the right towards our target. And if it's negative, it means we're going to be turning to the left towards our target. We're taking a dot product. I should use the left hand because Unity is left-handed. Dotting the direction I'm facing with the direction of my target. We'll get a positive vector for a right-hand turn. If I'm dotting to the left, I'll get a negative vector that's for a left-hand turn. Unity is left-handed. Everybody else in the world is right-handed. So I'm going to test my distance to the target. If I'm not too close, I'll set speed and direction using this dot product. So as long as my distance is greater than this inner distance, remember I mentioned the circles, I'm going to set the speed to 1 with the damping time. I'm going to get my current direction as my animator's root rotation. That's his orientation. multiplied by the forward vector. Multiplying a rotation times a vector gives you the vector in that direction. My wanted direction is the vector between the target position and the animator's root position. I dot those two. If it's greater than 0, I'm facing it, so I form the cross product. Take only the y component of it. Y is plus. However, if the dot product is negative, I'm facing away. So I'm again going to do the cross product, but this time, since I'm facing away, I'm going to turn as fast as possible. So I use one of these fancy ones where if this is true, if the y component is greater than 0, I'll do a 1 for a right-hand turn. Otherwise, I'll do a -1 for a left-hand turn. I do need to clamp these to be in the range -1 to +1. Since I haven't normalized these vectors, and we're getting, we potentially have directions that would be outside the range -1 to +1. And then I just set that float on my animator controller with some direction damping time, and I'm ready to go on. If this is not true, after some idle time has passed, I can, if I have some idle time, I'll reset the direction. And otherwise, if I've reached the target, if back here my distance is less than the inner distance, that means I've reached my target, and I would reset the direction. And then a yield return null, which ends this coroutine. So it would then go back way back here. That coroutine would end, and it would go around the loop again. So let me show you the WanderingAI here. There's my WanderingAI. I have a little circle here that shows that inner circle. Oh, come on, maximize. Maximize, maximize, play. Sorry. And wander. So here's my little WanderingAI. When he sets the direction, he's throwing that green circle out there somewhere. As soon as he's inside that circle has a radius of the inner circle. So he's wandering around, doing his thing, and periodically doing a dive or a jump as those random numbers come up. So very cool. So let's look at a following AI, one that follows the character. Now, this is actually going to be pretty easy, since the way we set up the Wanderer was that the Wanderer went to a target. And so most of the machinery we already have here. Exposed variables, I've got, again, this inner circle. I've got one common flaw of AIs is that they come right to the player and they bump up against them. And so instead, I'm going to have this distance in front of the player. Their target is the player, but it's offset some distance in front of the player, so that when the AI reaches the player, instead of bumping up against them, it stands out in front of them where you can see them, and that makes life a bit easier. So the start function, we're going to get our animator. With AIs, it's often good to give them a bit of randomness, and I'll do this by setting the animator's speed. This is not the speed parameter that controls the state transition. Animator.speed is how fast all the animation clips play. So this will make each AI move at a different rate. Their animations will still play exactly as they're supposed to, but their rate will go from 0.6 to 1.4 times their normal speed. If I don't have a target in my exposed variable, I'll find the player by tag. Otherwise, I'll use whatever target was in the exposed variable. And I'm going to start my while loop this time with a start coroutine seek. Seek takes the place of idle here. Start is a coroutine. It has type I enumerator, and that allows us to use the yield that is going to yield this. The seek function looks a lot like idle. We have the position that is the target position plus the target's forward vector scaled by the distance in front. So the position that we're seeking here is going to be out here in front of my player. The target is the player, target forward is the vector out the front of the player, and we're setting the position to be that point out in front of the player. If distance is outside the inner circle, we're going to turn the speed to 1, set the speed to 1. We'll calculate current direction and wanted direction the same way we did with idle. We'll do the dot product just like we did with the idle or with the wander script. And we'll do the cross product to get the direction. Again, setting it to the Y component if we're facing the player, and to plus or minus 1 if we're facing away, again clamping it to plus or minus 1 and setting its direction. Otherwise we're facing away. Otherwise we've reached our player. If the distance is less than the inner circle, then we've reached our player. So I'll set the speed to 0 and return null, and that ends the coroutine. So that looks like this. Follow. So there's my little character out there. He wants to be some distance in front of me. He's happy with that spot. If I move, he then chases after the green bubble, which incidentally is just a thing up in the sky above my character. And he's very happy to stay right in front of me. How rigorously you make him stay in front of you would be how big you set that inner radius. Okay, so we've got a wanderer and a follower. Fleeing is really quite trivial. It differs only from seeking in that the distance test against the inner circle is reversed. In other words, if we're too close, then we flee. And we reverse the sense of the wanted direction. So the wanted direction is now a minus sign. The speed is now, if we're inside the inner circle, we want to flee. But those are the only changes we make, and we can set it up exactly the same way. And now my little character, I should leave this running so that I don't have to start it every time. When we flee, there's the inner circle is that green bubble. If I move close enough, he starts to run away, and he'll run until he's outside the inner circle. As long as he's inside the inner circle, he's not very happy, and I can chase him. around the world. I'll leave that running since we'll come back to it. So we have wander, we have follow, we have flee mechanisms. Now, I'm going to combine some of these together into something I call a pet. The problem with the follow is the AI gets there and it just stands there and it doesn't do anything. But I'm going to combine idle and seek behaviors so that when the AI is close enough, it'll still continue to wander around. But if it ever gets too far away, it will switch to seeking and it'll follow the player. So our character will now have two behaviors, idling and seeking. Idling where it wanders around and seeking where it follows the player. I'm going to do this again with these two circles that surround our player, actually surround our target that the player will seek, offset in front of the player. When the pet is inside the outer circle, it will do this wandering idle function. If it moves outside that outer circle, it will seek and it will keep seeking until it's inside the inner circle, at which point it'll revert to idle. Let me say that again. If it's inside the inner circle, it will idle, it'll wander. If it ever wanders outside the outer circle, it will begin to seek and follow the player. And it'll do that until it reaches the inner circle, at which point it reverts to idling. That will then continue until it either wanders out of the outer circle or, of course, the player moves. Now, there are two approaches to doing this. One, we can write a program that has both idle and seek functions, or we can add as components both the wander script that does our idle behavior and the follow script that does our following behavior, and add a third script that will manage which of those two scripts is active. So over here in the pet scene, I have my teddy bear, and I'll close the transform and the animator and the character controller. Show target, I'll turn that off too. So I have a wander script, I have a follow script, exactly as I did for the individual characters. But now I have this seek wander manager that's going to decide which of these two scripts is controlling our character. We can turn scripts on and off from other scripts. So the seek wander manager has the outer distance, the inner distance. It has some Booleans, is wandering and is seeking, and it has cache variables for our two scripts, follow and wander, type follow and type wander, follow and wander. And initially these are false, the target is null, and inner and outer distances are specified. So start is going to cache the animator, it's going to find the player, it's going to get the two scripts that we need, follow and wander. It's going to set each of those scripts to be enabled false. This is going to turn off this little check mark next to the scripts when they're both turned off. And so initially here in start, both those scripts are off. No one is controlling our player. Now, this is a coroutine. It's an I enumerator, so we can use that yield statement. So if I have an animator, I'm going to again, do my random speed for how fast the animations play. And then I'll enter this while true loop that now has two functions. It has a start coroutine wandering and a start coroutine seeking. And because this is these are yielded, it means it's going to block on these. So when I start wandering, it's going to wait here until wandering finishes. When I start seeking, it's going to wait here until seeking finishes, and it's just going to continue to stir in this while true loop. Now, if you remember, I started off with both is wandering and is seeking false. So when I enter wandering, if is seeking is false, it's going to yield break, which means end this coroutine. Yield break stops the coroutine, and so it will go back to the main routine. Oh, but is seeking is false. Is seeking is false. So if this is true, is seeking is false, it's not going to yield break. So it's going to set is wandering to be true. It's going to enable the wander script. In other words, turn this one on, and then it's going to enter its own while true loop that is going to get the position in front of the player, form the distance. If the distance is greater than the outer distance, well, it's going to form the distance. If the distance is greater than the outer distance, that means it's wandered out of the big circle. I'm going to set is wandering to false, turn off the wanderer, and break. If distance is still inside that inner circle, it's just going to do a yield return null, which waits one frame, and this will continue to spin. So this is just mediating which of the two scripts, wander and follow, is controlling our character. Now the seeking script looks identical, except now if is wandering is true, we break. But of course, is wandering just got set to be false by the wanderer. And so it doesn't break. It sets is seeking to be true. It turns on the follow script that now controls our character. And again, we enter a while loop where we just figure out the distance to the position, check to see if it's inside now the inner circle. If it's inside the inner circle, it has found its character. So we said it's seeking to false, turn off follow, break. And if it's not inside the inner distance, yield a frame and go around the while loop. So with the exposed target, we can assign who the pet will follow. By default, it's the player. We could put a fixed target in the scene, and the pet would stay around that fixed target. We could put an invisible cube out somewhere, and the pet would just wander around it. Or we can get really fancy and chain pets together so that they follow each other around, all of which will get different behavior. So here's my pet. So there are the inner and outer circles. Now he's inside the inner circle, so now he's wandering. Let me turn on gizmos so that we can see some lines. Turn on gizmos, pet. Both the wander and the follow scripts have some debug lines in them that show the wanted distance, wander direction, and the current direction. And so as this thing is switching back and forth between its behavior, right now he's just kind of wandering around me. Every once in a while he goes outside the outer circle and then he comes back in again. And if I take off, and he of course follows me and eventually gets inside the circle and goes back to wandering. Here's a, well, this is a chain of followers, which one of them follows me. He's caught there. One of them follows me. The second one follows it. The third one follows the second one, and so forth. There's a chain of pets. I believe one of them is tasked with following me. So if I kind of pull away here, one of them follows me and the other ones all follow it. When they get close enough, they start to wander around each other. And here's a chain of pets where the first one follows the last one, the second one follows the first one, and so forth. So they're just all kind of randomly churning around, chasing each other and wandering around each other and doing all kinds of strange stuff. Just for fun, here's a follower that's following a fleer, and so the follower is going to keep chasing the fleers keep running away from the follower, and eventually they run off the world. Just to show you that this can all be done on terrain, here's a bunch of pets on a terrain, because these are Mecham characters with character controllers to run them. They work fine on terrains. They don't penetrate the terrain. This little guy in front of me is a follower, so he just wants to be in front of me, where he's very happy just standing there. The other ones are, of course, pets. And over here is a big guy who, if I chase, he runs away from me. And these are all using exactly the same animator. Oh, and here's the same thing, except now instead of teddy bears, I have the dudes for my characters, the dude that we did in the Mecham. And again, I did nothing but put the appropriate scripts on them, and away they go. The animations are all set up, and it uses exactly the same animator that we set up in the when we were doing the character. So all of that's pretty cool. Let me stop sharing here. Those are basic AIs. I believe if you look at the final game project requirement, one of them is that you have an AI. There is an advanced training that is AIs using some sophisticated scripting techniques. These are fairly simple, straightforward ones using just mono behavior scripts. But you can have a look at that if you'd rather see how those AIs work. You're welcome to use these AIs as your AI, and you can use my scripts if you want to. It's all fair game in here, but in your final game, there has to be an AI. And we're going to talk more about AIs. We're not done with AIs yet. I'm going to continue on with this in the next lecture. So I'm going to stop there. I'm going to stop recording, so I'll see you in class. Bye.